Okay. Integration. Integration is the opposite of differentiation. For differentiation, we use the symbol y dash. For integration, we use the integral sign, which looks like a nice long squiggly S. You probably have seen that around and you're wondering what it does. It just means integrate. And the way we say it is integrate 2x. You can't ever have just integrate of 2x. There has to be something that is attached to the integral sign, which is always going to be d, and then the letter that you're picking, or you're integrating. So if it was y's here, you'll do dy. But it's 99% of the time it's going to be x. So integrate 2x dx. What do we know the integral of 2x should become? X squared, of course, because we just said the opposite. So you're just going to go back up. So let's learn the rule. It's very simple. Keep everything the same, as always. You're going to add 1 to the power, because before you were subtracting 1. You're going to add 1 to the power, so what's 1 plus 1? 2. You divide by the power. So whatever this power is, you'll divide by that. And then what happens with the 2 and the 2? And then you're left with the x squared that we know. The only thing is with integration, you're going to, unless there's limits, which means there's numbers here and here. Let me show you what that means. There, like that. Unless there's limits, so if there aren't any limits, you've got to have a plus c. What does a plus c mean? It means it's a constant. Now, we don't know if there was a constant that existed or not. That's all. I'm no, sorry, I wasn't integrating that. That was just a random one up here that I chose. That was just a coincidence. So, all right, let's go. Question, and I guess like what you just said there, you now know differentiation. So when you see x squared, you'll quickly go, okay, what's the derivative of that? Oh yeah, 2x. Yep, I've done it right. And the answer is right in front of you. So here we go. How do we integrate 2x plus 5 dx? What does that become? Well, x squared plus 5x plus c. And again, integrate x to the 4. What does that become? X to the power of, you add 1 to the power, divided by the power, plus c. You getting the hang of it, Joey? You want to do the next one maybe? So integrate this, 3x squared. What does that become? 3x to the power of 3 divided by plus 2x to the power of 2 divided by 2. The answer is x cubed plus x squared. Oh, plus c. You will lose 1 mark for plus c. In your whole paper, sorry. But you don't want to lose 1 mark. Okay, x to the negative 3. You want to try it, Eden? X to the on plus c. Same rules as differentiation applies. So can you have x squared in the denominator like that? And can you have a surd? No. So same rules as before applies. So that becomes 5, take away x to the negative 2. And then when you integrate this, what does it become? 5x. You increase it by 1 minus x, negative 1 over negative 1 plus c. What does the 2 negatives make? A positive. So then technically we should have something like that if you've done it right. 5x plus 1 on x plus c. Last one. And then it's up to you guys. Vi root x. X to the half first, then you integrate. Every time you have it integrated, you've got to have the integral sign. When you integrate, you get rid of it. So x to the power of 3 on 2 Now, don't divide by 3 on 2. So the trick is this. The trick is this. If you're ever going to divide by a fraction, you should know that it's just the same as multiplying by the reciprocal of the fraction. So if you're ever going to divide by the fraction, you actually times by the reciprocal of the fraction. Just a bit quicker. Plus c. So that means if I had x 5 on 2, instead of dividing by 5 on 2, I multiply by 2 on 5. That's just the faster way of doing it. Only really poor students would probably still be writing fractions there in the bottom. And nobody should be doing that. Don't do it. Okay? It shows straight away that you haven't been practicing. Because if you've been practicing, you definitely would not be writing fractions in the bottom. Okay. Any questions, you guys at home? Easy? Yeah? No? Okay. Oh, you don't have to, no, it's just, that's okay. That was part of differentiation. Integration, not so much. Okay, you should be able to do all of this. There's just a few things I need to talk about. There's one more rule that I've just skipped, and then let's go through that. All right, integration is not like differentiation where there's like chain rule, product rule, whatever. It doesn't have rules like that, especially for advanced. There's only 2 cases. There's the one that we just did, those basic ones, and then there's this one. It's a question like that. So it looks like a chain rule. Some students think of it as a chain rule, whatever. The way it works is fairly simple, but it's very important that you do this. It's going to be 3x minus 2 to the power of 6 on 6 times the derivative of the inside. So you were doing that in kind of chain rule, if you remember, but in chain rule you were multiplying at the top. This time you're multiplying in the bottom, because integration is all about the denominator, because you're dividing. So differentiate the inside, 3. The answer is 3x minus 2 to the power of 6 plus c plus c. And we'll do another one. Square root 6 minus 2x dx. What's my next line? Make it to the power of a half. Next line. See how I still write my integral sign? Next line. 6 minus 2x to the power of 3 onto, then we times it by 2 on 3. 3 is times by negative 2. Wow, that was amazing too. Let's convert it back to a third, just because you asked that before. If I had to convert 3 over 2 as a third, top, bottom, bottom. That means that goes in the bottom, which is right there. That stays on the top. Over negative 3 plus c. That's pretty much one of the hardest questions you get in advanced. I'll show you the other hardest one, and that's it. Yep. Hardest algebraic one. Like there's obviously exponentials, trig, and so on. Numbers, yeah, but that's not hard. That's just type it in numbers. Top minus bottom, of course. Oh, this is actually really important. Integration finds area, of anything.
Like, couldn't you go back to the original?
No, but what if of anything? Like, what if you had to find the area of a river? What if you had to find the area of lakes, and what if I had to find the area of irregular shapes and so on? What if I had to find the volume of irregular shapes? Yeah, it's used. But integration is just, that's the basic version, area. It's used in like IT, in the computers, the algorithms, things to make them work. The calculus is huge. Pretty much all of university is calculus. If you're going to move on to math, it's not like algebra. Primary school, numbers. High school, algebra. University, calculus. That's pretty much how that works. Okay. Okay, there's no quotient rule. There's no quotient rule for integration, right? So you can't think, oh, okay, I've got to do it. You can't obviously just integrate this by integrating. Just go, oh, x cubed and then over 3 and then do, you can't do that either. So what you must do is get rid of the x at the bottom, and the way you're going to do that is by splitting it up. So it's going to look like this: x squared on x plus 3x on x, and then this x and this x cancels, this x and this x cancels. So the answer is x plus 3 dx, and then x squared on 2 plus 3x plus c. Product rule. -1. Oh, why would you bring that? I think that's a bit hard. I don't do that method. I like cancelling. So that's it. That would be the hardest one. Why? Because students don't know what to do with those 2 x's on the top and the bottom, but that's meant to be just done through cancelling. Easy? Very easy.